Hey guys, this video will be the first video in a series explaining how to make logic gates from transistors. In this video, we'll be going over the inverter, but before we go over the schematic, it's important to know what this logic gate does. So, if you look at this part here, you'll see that this inverter, what it does is it essentially inverts our signal. So what does that mean? So if we have an input that's high or a positive voltage, it's denoted as a 1, and our output is then going to be low or off. So basically, if we put in a voltage or signal through the input, we want no voltage or signal on the output. And basically vice versa. So if we put no voltage or signal through the input, we want a positive signal on the output, right? We want an on or voltage coming out through the output, and that's denoted also by this 1. So usually, instead of seeing this schematic in circuits, the inverter logic gate will be denoted by this triangle with the circle here, and this circle is used for pretty much anything that inverts a high signal to low signal. You'll see this on a lot of other logic gates. So let's get into the circuit now. So this is our circuit, pretty simple, just 2 NPN transistors, and this LED will act as our output. So if this LED is on, that's basically equivalent to the output state of 1, and if this LED is off, that's basically equivalent to the output state of off or 0. So, and this is our input. So if we put a voltage through this input, that's basically the same as a positive input or a 1 input. And if we don't put a voltage through here, then it's the same as a 0 input or off input. So let's go through these scenarios, how the circuit actually works. So let's say we do this scenario here, right? So our input is 0. We don't put a voltage through this transistor. So if we don't put a voltage through this transistor turns off, right? So let's just imagine we're the current, and we travel from the positive part of the cell, and once we reach this node, we can't travel through here, right? Because this transistor is off, so that acts as the open switch. So we then go through here, and then there's this junction. Because this transistor is off, there's also no voltage at the base of this transistor. So this transistor is also off. Because this transistor is off and it acts as an open switch, the current then travels through the LED and back to ground. So you can see by putting no voltage in the input, we have now gotten a signal on our LED. So by setting this to low or 0, we have turned on this LED, or basically put it in the 1 state. So you can see that matches this truth table. Having a 0 input leads to a 1 output. Now let's go over the other case, right? This 1-0 case. So if we put our input to high, right, we put a voltage through this. Hold up, let me just erase this. So we put a voltage through this input, right? We set this to the 1 state. This transistor then turns on, right? So if this transistor turns on, current will then travel through here, through this transistor, through the base of this transistor. Once there's a voltage across the base of this transistor will also turn on. So what that means is the current up here will go through here, but because this transistor is on, rather than going through the LED, it'll just go through this transistor and go back to ground, right? So basically what we've done is by setting this input to high, we've made it so that current no longer travels through this LED. And because it doesn't travel through this LED is now in the off or 0 state. So by setting this input A to high through this circuit, we can now set the output to 0 or in the off state. So basically that sums up everything you need to know, or the very basics of inverter circuits, the inverter logic gate, and I hope you guys enjoyed the video. Thank you.